Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video we will configure a lab 5.1.1.9 configuring basic single area OSPF version 2. This is part of CCNA semester 3. Okay, so I have opened my lab here, 5.1.1.9 configuring basic single area OSPF version 2, and I've got connection to my routers. All I did is erasing everything and reloading everything. I've got three virtual PCs. I've got PCA, PCB and PCC. Now we're gonna need to change IP addresses and so on. I was just testing early on. I've got a good connection with everything. Okay, excellent. So we're gonna complete the lab. First, look at the topology. This is the topology. I have configured the cables. I'm sorry you can't see it, but this is the physical routers. They are connected. We've got router 1, 2 and 3. Router 1 DCE on S000 and router 2 in S001, and then same for router 3 S000 is a DCE. Okay, so the first thing we're going to do, let me just go to the topology. Oh, sorry, the table, the addressing table. We're going to configure the table, the IP addresses. Right. Thing is here is at the step 3 says configure basic settings for each router. So what I like to do is actually configure all these settings and then just copy and paste it to my routers. So I'll do that in the notepad. So if I open the notepad, and this is from early what we were talking about. Okay, so let me just increase the font so maybe it will be a bit easier for you to see. I got 14, should be fine. Okay. First we'll enable, then after from user mode go to privilege mode, then I'll need to enter the global configuration mode by configure terminal. And then at the privilege mode, global configuration mode, first thing it says disable DNS lookup. So that command, no IP domain lookup. Okay, lookup. Then it says configure device name as shown per topology, as shown in the topology. So this is going to be host name, R1 for example. This is for R1. Assign class as a privilege exec password. So this means that when we accessing from enable, from the user mode to the privilege mode, we want a password class. So that will be enable secret class. Then it says assign Cisco as a console and VTY password. So I have to go line console first, console 0, password it wants Cisco. Okay, and then we have to say login. Then I need to move the line VTY 0 to 4, password Cisco, login. Then it says configure a message of the day banner to warn users to unauthorized access is prohibited. Okay, so we need to configure a banner. That will be exit here. I will say banner MOTD because that will be on the global configuration mode. Banner MOTD, and then we start with the character. So I'll usually start with a $, for example. So I'll say unauthorized access is prohibited. Okay. Now the next step says configure a login synchronous for the console. So I have to go back here in the console and say login synchronous. So login with 2 G's sync, and then configure an IP address as listed in the address table. We'll do that very soon. Set the clock rate and copy the running configuration to startup configuration. Okay, so what I need to do is just put this right at the end, right? So delete it from here. So enable config T, no IP domain, enable secret, all that. Just remove this. So it's gonna ask me in the end. Okay, so I'll copy all that. I will go to my router 1 first. So Control Shift 6 and X to go to the access server. Show session. Router 1 is in session 1. So if I press enter now, it's taking me to session 3. That sign there says that okay, if you press enter, you're gonna go to that session. but I don't want to do that. So let me go back to router 1. No, it says, would you like to enter the initial configuration dialog? Yes and no. This means that the router has looked for in the NVRAM for the startup configuration, didn't find anything, and it's asking you, do you want to start the initial configuration? Say no there. Okay. So I need to do the same thing for router 2 and router 3. So Control Shift 6 X and number 2 to go to router 2. I'll say no there as well. Press enter a few times. 2 times. Control Shift 6 X. I'll go to router 3 as well. Then I'll say no there as well. And press enter. Control Shift 6 and then to router 1. Control Shift 6 X to go to the access server. Then press 1 to go to router 1. And router 1 is ready. All I have to do now is just like copy what we did. So copy that configuration, go to the tear term and paste it there. Look, everything is fine, there's no errors, and the hostname is waiting for me to enter something. So I'll enter R1 here. Okay. And then we say copy running config to startup config. Okay, this we don't have to do it until we actually put the serial interfaces IP addresses as well. Anyway, I'll go to router 2, so Control Shift 6, let me just write that down, I don't have to type it again. If I'm in router 1, for example, say I'm in router 1, and I want to go back to the access server, yeah, I need to actually type a combination of the command, so Control CTRL plus Shift plus 6 together, and then release, and then press X. This will move me from router 1 to the access server, and then the access server I can choose if I want to access router 1, 1, if I access router 2, 2, and then router 3, 3. Okay, so when you see me doing that, I don't have to keep saying that. Okay, so I'm in router 1 now, I'll go into router 2 and do the same thing, just right click and paste them, all this stuff. Okay, and it's asking me for hostname or 2. I'm going to go to router 3 now and then paste that stuff. Okay, and say R3, so R3 there. Okay, I got all my 3 routers configured. Let me just leave that, so maybe you want to see it later on. Okay, I'll make a small separation here. The next configuration is going to be the IP addresses. So the IP addresses, now here it says G00, yeah. Don't wanna move it. Say select. Here it says G00. Now it's not actually G00. So if I go to say router 1, I'll move to router 1. I'll say show IP. I'll type in with the low letter. Show IP interface brief. You can see that I don't have G00. I have fast Ethernet 00, and that. And then it says S000, that's good because I have S000, but it says S001. For me it's S010. Okay, so you need to work around whatever you have on your router, kind of like put it to topology. Down here it does say, you know, if you read the notes, which nobody seems to be doing, if you read the notes it says, well, you have to look at it's not exactly the same as what we're telling you. You have to find out what interfaces are on your router. Okay, just so we know that. So I need to go to router 1, this configuration for router 1. So let me just make some space here. Go back up. Router 1. So interface, it was F00, given IP address. So IP address 192.168.1.1 and subnet mask /24. No shutdown. Okay, then I'm gonna move to S00 interface and give that IP address. So I'll go to small gap there, interface S00, as it says is DCE. So IP address 192.168.12.1 and /30, yeah. It is a DCE, so we need to put a clock rate 64,000 no shutdown. Now I'm going to go and configure the third interface, which is S010 for me. Interface S010, given IP address 192.168.13.1 and /32. Sorry, 30. This is not a DC, so I don't need to put clock rate. I'll just do no shutdown. Okay, excellent. Router 1 is done. So I need to do a small gap here. I'll do for router 2 as well. Now, I'm going to type it, but I'm going to, usually what I would do is I'll just copy this, put it here in router 2, paste it, and then just change stuff. So it says 192.168.2.1, so I'll change that to 2.1, router 2, yeah. Then S00 says 192.168.12.2, so 192.168.12.2, and it's not DCE, so I'll need to remove that. Okay, and then S001, it says 192.168.23.1, so S010 for me, 23.1, so 23.1, and this is a DCE, so I need to put the clock rate here, so clock rate 64,000. Right, so again I'm going to make a small gap here. The next config is for router 3. So again I'm just going to copy all that stuff from router 2, so copy that and paste it to the router 3 and just update it. Interface G00 says 3.1, so for me it's F0, so 3.1. S000 says 13.2, so 13.2 is fine, but it's a clock rate, so it is, so clock rate 64,000. Okay, let me just remove this because it's going to give us errors. And S001, S010 for me is 23.2, so I'll put that 23.2. It is not a DCE, so I don't need to put the clock rate. Right, so all the config for all 3 routers is done, and I'm just going to go and paste it. So I'll go and highlight router 1 stuff, right click, copy, go to router 1. If I paste them here, it's not going to work, so I need to go to config T first and then paste it. Pay attention if there's any errors. There's no errors, that's good, because otherwise it will see the underscore, yeah. So remember that if you do, for example, the last command, they say no shutdown, and if you make an error DT like that, SHUD instead of T, well, I just swap them over, we'll see the error will be like, oh, okay, well, here's an error, yeah. SHU was fine, up to here was great, but here you made an error. So pay attention to these markers. Okay, but when we configured it, there was no marker, which is good. Okay, so I'm going to move to router 2 now, and I'm in global configuration already, so I'll just go and highlight my configuration, copy, and go to router 2 and paste it there. Okay, now everything should, some of the stuff will go up, interfaces, and then I'll do the same thing for router 3. So I'll go to router 3, right click, copy. There was not any errors on router 2. Okay, so move to router 3 and paste it. As you can see, there's not any errors either. Okay, now I'm going to check it, see if there's communication. So if I go back to router 1, end here, then type show IP interface brief. Okay, I can see that I have serial interfaces, both of them are up, and my fast Ethernet interface is up. Let me just clear the screen. So edit, clear the screen. Right, so show IP interface brief, ping, let's try a ping. This is router 2, so router 2 address, I'm going to try and ping this address, so 192.168.12.2, and I have 5 exclamation marks, which is good, means it's working. So I'm going to ping router 3, so I'm going to ping this address, ping 192.168.13.2, and I have 5 marks as well, exclamation mark is working. I can't ping this address because it's too far. It's a remote network, and somehow I need to advertise it, either OSPF or static route. I can try it, but it's not going to work. 192.168.23.2, it will not work because it's a remote network. Okay, the dot means it's not working. So if I go to router 2 now and just check the interface between router 2 and 3, I can do it from here. So just type do. Now I'm going to ping that address. That is local connected for router 2. So do show IP interface brief. So this is the interface, the network 192.168.23, but the .2 is for router 3, yeah? So I'm going to ping that. So do ping 192.168.23.2, and I go, okay. PCs. Now, I'm working from PCB. Actually, PCB is using my physical interfaces, so you're not going to be able to configure. But I'm going to configure PCA and PCC just to make sure that we have a connection. So go to PCA and give an IP address there. Right, so TCP IPv4, and it was 192.168.1. I can't remember. So go to PCA.1.3. Okay, .1.3 and 255.255.255 192.168.1.1. Okay, and I'm gonna do PCCs 192.168.33. So I've got the PCC properties 192.168.3.3 255.255.255 and 192.168.3.1 is the default gateway. Just to say again, I'm using PCB as my physical interface. So if you look at PCB, it's got like a, let me just open the command prompt, ipconfig. I got different 192.168.1. Actually, that might actually make a problem. So we already have 192.168. Okay, let's see. PCA, if I do ipconfig 192.168.1.3, let's ping it. So ping a gateway 192.168.1.1, and it's great. I can ping my gateway. Go to PCC, open the command prompt, ipconfig. Okay, that's my IP address. So IPv4 address and gateway address 3.1. So I'm going to ping the gateway. So ping 192.168.3.1, and I have a reply. Okay. If I go to PCB now, okay, so cable and network done, initialize, we've done it, configure the basic settings for each router, which we did, including the IP addresses, including the setup the clock rate, and we do copy running config to startup config. Okay, so let's do that for the all PC. So end and copy running config to startup config. Okay, so I'm gonna copy that. So right click, I'm doing Control C, but so you can see it, right click, and then I go to router 1, right click, paste it. Okay, end was a problem because end was on, it was already on the privilege mode. End takes you to privilege mode. Okay, router 1 is done. This thing, done it, saved it. I go to router 2, paste that. Here is fine. Router 2 is doing its thing, and then I'll go to router 3. I'll do the same thing. Okay. Test connectivity. The router should be able to ping one another. Yeah, we've done it. Each PC should be able to ping the default gateway, which checks PCA and PCC. Did it fine. PCs are unable to ping each other until the OSPF configured, and it's done. Until we do the OSPF, they're not going to be able to ping each other because they are in a different network. So I can try it. So ping 192.168.3.3, it's PC3, and the gateway is telling you, no, I don't know how to get that. Okay, so configure and verify OSPF routing. So in part 2, we will configure OSPF version 2 routing on all routers in the network and then verify it. Verified tables are updated correctly. After OSPF has been verified, you will configure OSPF authentication. Okay, excellent. So let me make some gap. I'll do everything in Notepad. Okay, here, we start from here. So this configuration is for router 1. So router 1, and I say router OSPF1, right? This is the process ID. Use the router OSPF command in global config mode to enable OSPF in router 1. The OSPF process ID is kept locally and has no meaning on other routers on the network. So it doesn't matter what you put on the other routers. Configure the network statement for the networks on router 1 on area 0 with area ID 0. Now router 1 has 192.168.10, 12.0, 13.0, the networks. So if I go back a little bit, you can see we can advertise this network, this 3 networks, yeah, like that's router 1, yeah. Okay, so network 192.168.1.0, and the wildcard mask of this is the inverse of subnet mask. So that's going to be 0.0.0.255, and we put them in area 0. Here 192.168.12.1, so actually we put the network 192.168.12.1, that's IP address of the interface. The network is 0, so 0.0.0.3 is the inverse mark or wildcard mask, area 0. Network, the last network 192.168.13.1, oh sorry, 0, and then network. Right. What I tell my students usually, put the interface ID, so 12.1 for example, and now here put all zeros. So 192.168.12.1, 0.0.0.0. That's easy. We are just enabling for this interface IP address, not for the network. You don't need to do it for the network. But anyway, that's what it's telling us. Configure OSPF on router 2 and 3. Use router OSPF commands. Here it's telling us for router 1, but it's actually expecting us to do it for router 2 and 3 as well. Okay, so router 2, these are the addresses. So if I go R2, now like I said before, I can just copy this and just change some of the stuff. So copy that. Router OSPF1 same. 192.168.2.1. So this one I'll change it to 0.0.0.255. 192.168.12.2. So this one I'll put it back to what it was, like that. 192.168.23 network. So change this to 23. And then now I do it for router 3. So just highlight, copy, and this stuff here is for router 3. So router OSPF1, 192.168.3.0, 192.168.13 network. So this 13, 192.168.23, that can stay the same, right? So we're done. Okay, so if I just highlight router 1 stuff, go to router 1, Control Shift 6X, 1, config T first, and then just paste it there. Done. No errors. See, that didn't give us error. Okay, so I'll go to router 2 now, Control Shift 6X, 2, config T, go to my notepad, copy my notepad stuff, and paste it there. Now there should be a neighbor coming up between router 1 and 2. That's it. So see, this is like a syslog message for us. It says OSPF 5 adjacency change, process ID 1, neighbor 192.168.13.1 on serial 0000, form loading to full, loading done. See, the neighbor router 1 has picked this as an IP address, as a router ID. This IP address is the router ID. If you look, these are the all router ID. We did not type router ID ourselves. That's the first precedence. There's no loopback. Since there's no loopback, it's picking the highest IP address on the physical interface. And this one is the highest IP address on the physical interface. So if I go to router 2 and I say show IP OSPF neighbor, now that's it. That's my neighbor. Okay, so if I go and copy the commands for router 3, copy, and go to my router 3, config T, and I paste it in. Now there's going to be two neighbors between router 1 and router 2. There you go. 192.168.13.1, that's router 1, that's the ID. And router 2 has picked the highest physical interface, which out of these three is this one. This one here. What do you think router 3 has picked up as a router ID? Well, we didn't say router ID. There's no loopback interface, so the highest IP address is this one. We can go and verify. So if I go to router 2 and I say show IP OSPF neighbor, you can see 23.2 is the router 3 ID. Okay, now show IP OSPF neighbor in router 1. So if I go to router 1 and I do end here, show IP OSPF neighbor. Now you can see 192.168.23.2, that's router 2, and priority is 0, is full, the state, it's point to point, and dead time is running down. The address 192.168.13.2 is the neighbor's IP address, and that's my interface, 0010. That's towards router 3. That is router 2, 192.168.23.1. See, it gets a bit complicated if you don't do the router ID. You'd rather do the router ID here. Okay, so if I do show IP route, now from my routing table, I got two networks that I know about, that I learned. I learned LAN of router 2 and LAN of router 3. So 192.168.2.0, that's a network of router, or local area network of router 2. And that's a local area network of router 3. You can see administrative distance is 110, and that's a metric cost of 65. That's a neighbor's IP address. That's how long I know my route, and that is the interface I'm learning this route from. Okay, and one more. Sorry, I didn't see that. That's actually the interface between the router 2 and 3. You know, the serial interface between router 2 and 3. What commands would you use to only see the OSPF routes in the routing table? So what commands if you want to see only OSPF? Well, we type show IP route, and now we have a choice, right? OSPF, just OSPF. So I don't want to see everything. I don't want to see directly connected routes and so on. So these are only my OSPF. So verify the protocol settings. So show IP protocols. Sorry, not show IP route. Protocols. Right, what we can see here. Here, for example, we can see what is our process ID, what is our router ID, and what networks we are actually sending, or we have enabled in OSPF, plus the distance, administrative distance. The next is use the show IP OSPF command to examine the OSPF process ID, router ID. This command displays the OSPF area information as well. Okay, so, and if we are using any algorithm, so show IP OSPF. Right, here is quite more information that we can see, but first on the top there, we can see OSPF1, ID as well, and we can see the algorithm, if there is any algorithms, or how many times the algorithm ran. So shortest path first, algorithm last executed 3.5 minutes ago, and how many times has the algorithm been run? So algorithm has run 3 times in total. Areas, ranges are what areas do we have, and any other information useful for us here? Not that much. Okay. Oh yeah, what area we are? We are in area 0. Yeah, so the algorithm for that area. So if it was other areas, you will see another bunch of lists like this for other areas. This is a good command. Show the next command, show IP OSPF interface brief. This tells you what interfaces you have enabled for OSPF. For example, we have enabled in all our interfaces, what areas do they belong, and the important thing is the cost as well. We can see what's the cost and what type. It's point to point, yeah, point to point, and this is multi-access. Right, the next command is show IP OSPF interface. For more detailed information about OSPF, show IP OSPF interface. Right, more information without brief. Yeah. Here we have quite a lot of information. First we see what area we belong, what is our IP address, what type of network is it, point to point, the metric, the cost. Important things here we can see is it gives a show IP OSPF interface, yeah, the hello and dead time. So hello is 10 seconds and dead time is 40 seconds. And what is our adjacent neighbor width? This information here is about serial 010, right? So we have one neighbor, 192.168.23.2. Okay. To change the router ID, the first thing we have to do, for example, say show run here. If I go all the way down to OSPF configuration, so router OSPF1, for example, we have not configured router ID. So router ID, for example, we have to, we can do it three ways. We can configure router ID manually. We can pick the highest loopback address, well, set the loopback address and pick it, and or highest active IP address. Because no router ID or loopback interface has been configured on the three routers, the router ID for each was determined, the highest IP address of an active physical interface. In part 3, you will change the OSPF router ID assignment using loopback address. You will also use the router ID command to change router ID. So step 1, change router ID using the loopback address. Assign an IP address on the loopback 0 on R1. So if I go to R1, so this config here is for R1. Let's make small gaps here. Here it's telling us to create an interface, a loopback interface. So interface loopback 0, give an IP address 1.1.1.1 /32 mask. We don't need to do no shutdown because it's a loopback interface, it will go up right away. So assign an IP address and loopback 0 on R2 and R3. Okay, so we have to do the same thing for R2 and R3. So it's easy, just copy and paste. So R2 and R3, and I need to put 2.2.2.2, and this one is 3.3.3. Okay, save the run configuration. You must reload the router. Okay, so we need to save it. So let me just put it here. Okay, now some of the routers on your lab, they might not save the configuration. So if you save them and reload them, it might not work. On my lab, they will save the configuration because the configuration register on the router, it might be set not to save the running configuration. So be careful here, yeah, that's all I'm trying to say. Okay, so after we do end, we have to say copy running config to startup config, and then reload. Okay, yes, all that, enter a few times, then reload, and that's it. I'll just copy this stuff, I'll put it on the router 2 and router 3. Okay. Now if your register on your router is not saving any config, what you have to do is this, say no router OSPF, and then apply a new router OSPF, and it will pick it up. But if it is saving them, great. So I'm just going to highlight, copy, go to router 1, config T, and paste it there. Okay, interface loopback 0, IP address, and copy running startup config. We've done that. Reload, and reloading is happening in router 1. So if I move to router 2 now and copy the router 2 stuff, config T here, and paste it. Okay, now router 2 should be reloading as well, and then for router 3, copy, go to router 3, and paste it there. Okay. Okay, after the router complete the reload process, issue the show IP protocols command to view the new router ID. Okay, so if I go to router 1, and hopefully router 1 has done. No, still waiting for it. Then we do show IP protocols, and new router ID will take effect. Router ID 1111. Okay, well, I'll pause the video a little bit, so you don't have to wait. Okay, I think router 1 is done. Let me just press enter. Not there, not there. Go there, press enter. Okay, that's what was it? Cisco, enable, and it was class. Now show IP protocols. And yes, new router ID has taken effect. The one that we configured, 1111. If I say show IP OSPF neighbor, then the other two routers as well is taking effect. Okay, that verifies it. Now, if this doesn't work, if your configuration register on routers is not saving the whatever you do, copy startup config to copy running config to startup config, you have to erase the OSPF, the whole OSPF. So you have to actually type here like this, no router OSPF, and then copy that back, and then copy the whole thing back, and then you'll see it taking effect. Okay, so change the router ID on the using the router ID command. Okay, so this is the better step. Actually, look back is not the greatest. So do it this way. This is the better method. So router, we go to router OSPF1, and then say router ID for router 1. It says 11, 11, 11, 11. So used to write in 111, right? So issue the router ID 11, 11, 11, 11 command on router 1 to reassign the router ID. Notice the information message that appears when issuing the router ID. Okay, says reload or use clear IP OSPF process command. Okay, so let's do this. Go to router 1, config T here. Let's clear the screen a little bit. Okay, so paste that. That's the message. It says reload, shut down, switch it off and switch it back. Or use clear IP OSPF process command for this to take effect. Right, we don't want to reload again, we just use that command. So go to privilege mode and type clear IP OSPF process. And the router says, yeah, sure, you want to clear it? And say no. Yes. Right. Now all the neighbors are going to go off, and then going to go down. We're going to erase all the routes that we're learning from them, and then we're going to rebuild it again. Now when we say show IP protocols, we can see that we have now a new router ID which is configured. This was easier way to do it. Okay, so what we did here, after we configured that, we send end and say clear IP OSPF process, and then there was a message, do you want yes or no? Say yes. Okay, we're going to do the same for router 2 and router 3. So router 2 here, I'll just change this 2 and this to 3, and the command 22.22.22.22, and router 3 is going to have 33.33.33.33. I think that's what it's saying down here. Okay, we're going to do the same, copy for the router 2. So if I go to router 2, okay, I need to log on Cisco, enable, class. Okay, we didn't verify it. Show IP protocols. See, it picked up from our loopback interface. Show IP interface brief. See, it's picked up from this. Now we don't want to do that. We want to actually do router ID. So, sorry, don't want to paste that. Go back here, copy, and paste it. There you go. Show IP protocols. See, that takes effect. Yep, we have new router ID, and we're gonna do the same for router 3. So copy, go to router 3, Cisco enable class config t. Okay. No, I don't want to bleed m. You see, as soon as you highlight something, that's on the memory. So paste that. Yeah. Okay. Show IP protocols, and we can see that we have a new router ID. Excellent. Now the interfaces are we need to configure the passive interface. Configure a passive interface. For example, the interface G00, we should not be sending hellos, yeah? So if I go to router 1 and say show IP OSPF interface FA00 for me, now you can see that hello messages are going every 10 seconds. Next hello is going to send it every 2 seconds. Now this is a security risk, as well as we're wasting the bandwidth. So for that reason, we want to make this interface as a passive interface. The command to do that, so you have to go to, not there, just make a small gap here. So you have to say router OSPF1 and then say passive interface FA00. Right. That's one way of doing it. This is for router 1. I was thinking earlier, is it OSPF1 or OSPF10? I think it's OSPF1. Yeah, process ID 1. Okay, so router OSPF1, passive interface FA00, passive interface 00, FA00. So, but the best method would be if I do it in router 2 there. I'll go router OSPF1, I say passive interface default. So I'm making all the interfaces to passive, and I have to say no passive on the interfaces that I don't want. I want them to send hello. So no passive interface S000 and no passive interface on S010. This way is better, because if you create a new virtual interface, if you create a logical interface like a new I don't know, loopback or something, you have to make sure you have to go in there and say, oh, a passive interface, and so on. Okay. So here, let's do router 1 first. So, oops, control, copy, go to router 1, config t, and paste that. Okay, if I do show IP protocols now it says here passive interface FA00, right? Try here we say it's to find out what interfaces are passive. Never mind, there's no hello passive interface. You can do it that way. So show IP OSPF interface G00. There's no G here. F00, and it says no hellos. We're not sending. But the best way to find it is show IP protocols and find out what is a passive interface. The thing is that if I did this passive interface on router 2, right? If I just do it like this, now router 2 has got one interface like no. Hold on. If I go there, if I go to router 1 has got one interface again. Show IP interface brief. If you do it like this, see this interface here? It's not passive either. This is passive, we just said it, but this is not. We didn't do it. So that's the reason this will be better. And then just the no passive on the ones that you do want. So if I say show IP protocols, for example, you can see that it's only passive interface FA00, but there's no passive interface on the other interfaces. So for example, say loopback 0, show IP. OSPF is not enabled. We haven't enabled OSPF on this interface. But anyway, if you did, it will not work. So better this way. Okay, so control copy, go to router 2, config t, and then paste them there. here we have a problem. I have misspelled it, so that's the best way to. Every time there's a problem, make sure that you do look at these markers. Okay, state is being long, so that's why it's taking a long time. Here, a router, OSPF1. Let's try it. Copy. Paste it. Yeah, that's fine. Okay, we're gonna do it on the issue the show IP root command on router, verify the it's still available. Okay, once we do it to router 3 as well, let's do that for router 3. Router 3, same command. Router OSPF1, passive interface default, and no passive those two interfaces. So we go in router 3 now. Config T. The only problem with this command will be that you see it's resetting all the interfaces, or all the neighbors are going down, and then neighbors are coming back up as well. PCC just went. It's tired. Resume. Okay. So end. If I do show IP root, sorry about this. Okay, what we don't want to see everything, just see the OSPF diagram. Show IP root OSPF. Now you can see, even though that we did the passive interface, the interface is still, or we still have a network to that LAN. Show IP OSPF neighbor, set passive interface as a default. Yeah, I've done that. I was ahead of you guys. Yes. Okay, reissue the show IP OSPF neighbor. Yep. Show IP OSPF interface. No hello message. Passive interface. Yeah, this is telling you that you do have to have no passive interface. If you do passive interface default, you are putting passive everything. So even the S00 will be in the passive mode. So you have to go to the and say no passive interface. Whatever the interface you do want to send hellos. What interface R3 using this root? What interface is R3 using the root 192.168.2.0 network? Right? So R3 to get to the network 192.168.2.0 is using this interface. What is the accumulated cost metric for the 192.168.2.0? Right? Cost metric is 65. Does the R2 show up an OSPF neighbor on R1? Yes. Does R2 show up on OSPF neighbor on R3? What does the information tell you? Okay, so if we say show IP OSPF neighbor, sorry, show IP OSPF neighbor, we can see the router ID. What the router ID? Oh yeah, that's the one that we changed. That was a new one. I thought it's supposed to say 1.1. No. Okay, we can see the router ID. We can see the priority and the state. How dead time, address, the neighbor's IP address, and the interface. Change interface S001 on R2 to allow the advertised OSPF routes. Yeah. Okay, reissue show IP route. Okay, so part 5 says change OSPF metric. In part 5, you will change OSPF metric using autocost reference bandwidth command to the bandwidth command and the IP OSPF cost command. All DC interfaces should have configured with the clock-in rate of 12800 in part 1. Okay, well we have made a mistake there. This is useful of Notepad, yeah. So the clock rate, if I go back, it says it should have been configured with 12800. Okay, that's 1. So if I copy that, what I'm doing, Control C, yeah, copy that, Control V. Alright, so if I paste all this stuff, right click, copy, very quickly on router 1, so Control Shift 6 1, Config T, paste it. Yep, good, no problem. I don't need to do the whole thing, I'll just do this for router 2. Okay, go to router 2. And then for router 3 as well. Copy. Okay, excellent. Done. Now change the reference bandwidth. The default reference bandwidth in OSPF is 100 megabits per second fast Ethernet speed. However, most modern infrastructure devices have the link that are faster than 100 Mbps. Because the OSPF cost metric must be an integer, all links with transmission appear of speeds of 100 and above will equal to 1. The result in fast Ethernet, gigabit Ethernet and 10 gig Ethernet and the future higher speeds will all equal to 1, and OSPF will treat them as same speed. Right. Show IP interface G0 is going to be different to mine because it's F0. The bandwidth setting on G0 might differ from what is shown above if the PC's host configuration only supports fast Ethernet. So even if you have a gigabit on the fast Ethernet, gigabit Ethernet on the router, PCs are fast Ethernet, then it's not going to work. It's going to revert to fast Ethernet. Okay, so if I go to router 1 here and show IP route OSPF, I can see it is 65 set. So 64 for the serial interface plus 1 for the fast Ethernet is 65 to the LAN. So if I say show IP OSPF interface A00, the cost here will be 1. And the serial interface, the cost is going to be, if I do 64, yeah? So 64. How we get this 1 and 64 is the formula, right? So the formula is the sum of the cost of these two interfaces is accumulated cost for the route to the network, fast Ethernet 1 and the serial interface 64. Now we do the reference bandwidth divided by bandwidth, it will equal to the cost. Now I have a photo viewer that we can look at. The reference bandwidth is stored in documents. So this is the default reference bandwidth, which is 100 million divided by the actual bandwidth of the interface. So if you look 100 million for fast Ethernet divided by 100 million, that's the actual interface in bits per second of the fast Ethernet, equals to 1. But that the same is going to be equal to 1 for for gigabit Ethernet and 10 gigabit Ethernet. For example, for gigabit Ethernet, reference bandwidth 100 million divided by 1 billion still going to equal to 1. And 10 divided by 10 million equals to 1. So as far as OSPF is concerned, all those three interfaces are exactly the same speed, the cost of 1. So if I do, for example, show IP route on the router 1, so if I say show IP route OSPF, now this is towards router 2, the LAN of router 2, the administrative distance 110, but the metric or the cost is 65. So the cost towards the router 2, the serial interface, cost of 64. See that serial interface, cost 64. Plus the 1 is fast Ethernet, so 65. So if I go to router 2, show IP OSPF interface, say S000, that's towards router 1. Router 2, I'll go to router 2 now, and I'll do show IP OSPF interface S000. You can see the cost there is 64. That is because the serial interface, 100 million divided by the serial interface bandwidth, that's a default bandwidth, is going to give me 64. Now if I do same thing but for fast Ethernet 00, the cost is 1. So as you can see, router 1 has accumulated, okay, to get to this LAN of router 2, it's going to cost me 64 towards the serial interface plus 1 towards the local area network of router 2. Now to change the reference bandwidth, we go the command. For example, if you don't have any faster Ethernet, for example, everything is fast Ethernet, there's no point to change auto cost reference bandwidth. But if you do have a faster interfaces, then yes, you do have to change it. When you change it, you make sure that you change it everywhere, on all the interfaces, all OSPF routers. So we need to go to router 1, for example, and say auto cost reference bandwidth, cost reference bandwidth, 10,000. Now let me just copy this. I don't want to make a spelling mistake there. Copy this text, put it here. There you go. Now we have to do it for all 3 routers, yeah? So we have to do it for router 2 and router 3. As soon as we do this configuration, the router is going to say to us, it's going to remind us that we have to do the same configuration on all 3 routers. Okay, so I'll paste that. It says reference bandwidth is changed. Please ensure reference bandwidth is consistent across all the routers. So we change that. Now, because we increased the reference bandwidth before it was 1 and 64, so let's do that to router 2 and go back and change it. So before we change it, look, it's 64, right? So what we're doing in the reference bandwidth, we're adding 2 more digits really. So okay, let's just paste that. So if I copy the configuration, and I don't want to paste it there because it won't work. Paste it there, and then do show IP OSPF interface S000. Now the reference bandwidth is not just 64, it's 6,476. So you kind of like making division there. So that will be 100, that will be 10, and that will be 1. So if I go to now the interface of the fast Ethernet, F00, see, that's going to be 100 now. Okay, so you just increased by 2 more zeros the reference bandwidth. The change of bandwidth for the interface, we can do the same, but instead of leaving the interface default bandwidth, we can go and change the bandwidth of the interface. For example, look at the router 1. So we go to router 1 and show interface as 000. T there, what's 1 T there? Now you can see that 1544 kilobits is the default bandwidth, so we can go and change this to make effect to our router. As well as, not to drag it too long this video, we can change the cost of the interface per interface rather than do it on like this with the bandwidth or auto cost reference bandwidth. Don't let the OSPF calculate it at all. We can just change the cost automatically. Show IP OSPF interface brief. For example, it says the cost for fast Ethernet is 100. We can go and change it. So go interface FA00 and then IP OSPF cost, say 500. And then we didn't let the OSPF do the calculation. We told exactly what do we want that cost to be. Okay, so down to the cost is going to be, the OSPF is going to choose the fastest path. So the metric for the OSPF is the cost, which is derived from the reference bandwidth divided by actual bandwidth. Okay, this has been it. This is the lab we covered, 5119. I'm sorry, it did take quite long, but we went through in thorough. Right, hopefully I'll see you in the future videos, and please do not forget to subscribe. Bye bye.